Hi fellas, this is Chemaddicts again to the solution. Welcome back to another video tutorial. Well fellas, now today we're gonna solve question 19 of this question paper. So let's get started. Okay. At first let us read the question. A titration experiment was used to find the percentage of iron in iron tablets, the volumes used and measurement uncertainty for each reading of the burette and pipette are shown. So here basically what we are doing here is we are measuring the percentage uncertainty of each of each apparatus. Okay, so here the name of the apparatus is given, two apparatus, that is burette and pipette. And here volume used is noted over here for each apparatus, and measurement uncertainty of each apparatus is given. Okay fellows, so what is meant by measurement uncertainty? So measurement uncertainty is the measurement of the smallest possible volume of burette. Okay, so that is, in other words, we can say that the smallest volume of a droplet. Okay, so the volume of the droplet is the volume uncertainty, okay, of burette. So small droplets have a volume of 0.05 cm cube of burette in burette, so that is why that is the uncertainty of the burette. Okay, so in the same goes with pipette. The smallest possible volume that can be measured from pipette is 0.06, just like burette. Okay, slightly different. Okay, so here in pipette the volume used is also measured and the percentage uncertainty is also given. So what is the question? Let's read. What are the total percentage uncertainties to two decimal places? Okay, so here we need to calculate the percentage uncertainty of these two apparatus given. Okay, so in here let's just discuss some of the things before solving this question. Okay, so when we are calculating the percentage uncertainty of burette, okay, in burette what we actually do, we actually take reading two times. Okay, so in burette, sorry for my handwriting fellas, my handwriting is really bad, I know. So in burette we take reading two times. So we take reading two times. One is the initial reading, one is initial reading and another one is final reading, just like this. It's the burette, bad burette, just kidding. So here we measure from the lower meniscus. Since we measure from the lower meniscus, so we take the U shape of the meniscus. Okay, so in here let's just consider this point and this point. So here we gonna have initial reading, and here we gonna have final reading. Okay, so this is the change in volume. So what we actually have measured here is the volume used. Okay, so this is the volume used just by taking the reading of initial volume and the final volume, and we just find the difference between these two one. So this is how we gonna calculate the volume used, and the uncertainty would be two times. Since we have taken reading two times, so the percentage uncertainty will also be two times. Okay, so in here the percentage uncertainty will be two times. So this is how it gonna goes. In pipette, we take reading just like this. We take, no, not like that. We take reading one time. Okay, so in burette we take reading 2 times, that is the initial volume and the final volume, and in pipette we take reading 1 time. Since there is no initial reading or final reading in pipette, we just take 1 reading, that's it. So that's how it is measured. So let's just summarize this thing up. Okay, so in burette the percentage uncertainty in burette we take reading 2 times. So we take reading 2 times since there is initial reading and final reading. Since we have to take initial reading and final reading, so that's why the reading will be 2 times. In pipette the reading would be 1 time, since we are taking just 1 reading in 1 chance, that's it. Okay, so that's the thing. So now let us calculate the percentage uncertainty of burette and percentage uncertainty of pipette. So percentage uncertainty, okay, of burette would be like this. So first we need to take the uncertainty volume, that is 0.05. since we are taking 2 times reading 2 times, since we are taking reading 2 times, so we need to multiply this by 2 and divided by the volume used, which is 21.8 multiplied by 100, which will give us as 0.46. okay, and now let us come over here, percentage uncertainty of pipette. So here this should be like this. We will take the uncertainty volume in the numerator 0.06. We are taking the reading this, okay, we are taking this reading. So here this is 0.06 divided by the volume, which is 25, volume used multiplied by 100, which will give us as 0.24. So here let us just concentrate on pipette. Okay, so how does we transfer liquid by pipette? Well, so we have suppose the solution is in the volumetric flux. We dip the pipette into the volumetric flux and we suck using the sucker, or which suction pump. We just take the whole liquid in a whole chance, and there we don't take any reading. Okay, and after that we transfer that liquid into the conical flux by pressing the suction pump, and the whole liquid just fell off and we don't take any reading, since in the pipette there is a mark. Okay, since in pipette we have individual pipette, specific individual pipette that is measured, just like 25 cm cube pipette, 100 cm cube pipette. So that is why we are taking reading 1 time, just the reading of that pipette. Okay, since pipette exists in individual parts, just like 25 cm cube or 100 cm cube, the whole pipette is 100 cm cube, whole pipette is 25 cm cube. So that is why we take reading 1 time. But in burette there is a graduation mark in the burette, so we need to take the initial reading and final reading in order to find the change in volume, So that is why in burette we gonna have 2 uncertainty, and in pipette we gonna have 1 uncertainty. So that is why we need to multiply the uncertainty into 2 in burette, and we need to multiply this uncertainty with 1 or standalone in the pipette, since we are taking reading 1 at a time in pipette 1 time. Okay, so fellas, that is why the answer should be C. C is the answer. Okay, C is the answer to this question. So fellas, I hope that most of you fell trap of D, since we have multiplied 2 times by in burette we have multiplied 2 times, and in pipette we have also multiplied 2 times. So that is why the answer seems to come like this, but this is not the answer. The answer is C. Okay, so I know fellas, you most of them have chosen D, but D is not the actual answer. Why? That's because we have already multiplied 2 times in burette, so that is why this matches with this answer. But in the case of pipette, we are not supposed to multiply this thing with 2, but we have done a mistake over here. We have multiplied this thing by 2 in option D, so that is why the answer would come as D. So that is not the real answer. The real answer should be C. We just need to multiply in burette by 2, okay, not in pipette. So let me get this clear. Okay, so that is why the answer should be C. So fellas, I hope that you have understood the question as well as the solution. Okay, so if you have any question, if you still have any question regarding the concept behind this thing, please let me know in the comment below. Okay, so by this meantime, let us move on to the next question. So let's solve question number 20. Sulfuryl chloride reacts with water to give a mixture of sulfuric acid and hydrochloric acid. How many moles of sodium hydroxide are needed to neutralize the solution formed by adding 1 mole of sulfuryl chloride to excess water? Sulfuryl chloride reacts with water to give a mixture of sulfuric acid and hydrochloric acid. How many moles of sodium hydroxide are needed to neutralize the solution formed by adding 1 mole of sulfuryl chloride to excess water? Okay. So in order to solve this question, we first we need to construct a chemical equation for this reaction. Okay, so in here, what is actually happening? Sulfuric chloride reacting with water. So here, this is the sulfuric chloride, SO2 Cl2. Okay, reacts with water, H2O, forming sulfuric acid, H2 SO4, and 2 moles of HCl. So at first, let us balance this equation in order to solve this question. Since the moles are involved over here, so we should balance this equation, otherwise the answer might come wrong. The answer would be wrong. Okay, so here we have 2 chlorine on the left hand side, and on the right hand side we have 1 chlorine. So for that we need to add 2 over here. So now we have 4 hydrogen, 2 hydrogen, 2 hydrogen. That comes as 4 hydrogen on the right hand side and 2 hydrogen on the left hand side. So here we need to multiply this by 2. So that is why this is 4. Okay, now so now the equation is balanced. Okay, so here sulfur is balanced, oxygen here is 2 4 okay, balanced. Then chlorine balanced, then hydrogen balanced. Okay, the equation is balanced. Okay, now here is the main part. Okay, so when we give sodium hydroxide solution to this solution, okay, to this mixture, here sodium hydroxide is a strong base, right? Here we also have 2 strong acid. Here sulfuric acid is strong acid, as well as HCl is also a strong acid. So this strong base will react with sulfuric acid as well as hydrochloric acid. So that is how it gonna react. Okay, so this sodium hydroxide will react with these 2 acid in one word. So here So in here since we are considering these both acids, so we already know that acids are proton donor. Okay, so it gonna donate protons. So in sulfuric acid, in 1 mole of sulfuric acid, it gonna donate 2 protons. Okay, 2 H plus ion. And in 2 moles of hydrochloric acid, it gonna donate 2 H plus ion. So 2 H plus ion, 2 H plus ion will be 4 H plus ion in total. Okay, so since 2 H plus ion is over here, so there should be 4 H minus ion in order to neutralize this H plus ion. Okay, so in concept we already know that, in another concept we already know that in a neutralization reaction, same amount of hydroxide ion neutralizes the same number of H plus ion. Okay, so the same number of moles of hydroxide ion should neutralize the same number of H plus ion, that is the mole ratio of hydroxide ion to H plus ion should be 1:1. So here is the basic equation for a reaction. Suppose sodium hydroxide is reacting with HCl. Okay, then the reaction would be like this. So basically this is the basic neutralization equation. Okay, chemical equation. This is the basic chemical equation for the neutralization reaction. So for a basic chemical equation for a neutralization reaction, in a basic neutralization reaction, here the mole ratio should be 1:1. So in order to fulfill this condition, we need to do like this. Okay, so we need to keep the hydroxide ion and H plus ion to the mole ratio of 1:1, then it's gonna work. Okay, so in a neutralization reaction, the same number of moles of hydroxide reacts with the same number of moles of H plus ion to form water. Okay, since in here we have 4 moles of hydroxide ion and 4 moles of H plus ion, we need to have 4 moles of water. Okay, so 4 hydrogen, that gives us 8, and in here 4 to the 8 hydrogen, oxygen is 4, and that's how it gonna work. And in here, if you have noticed, in a basic neutralization reaction, in here the mole ratio of hydroxide to H plus ion is 1:1, and in hydroxide and in H plus ion, and the mole ratio between H plus ion to water is 1:1. So this is how it goes, 1:1:1. This is the basic neutralization reaction. Okay, so that is why the answer should be D, not B. I know, fellas, that most of you have chosen B, and B is not the answer. Okay, since we need to fulfill this condition over here, this special condition that in a neutralization reaction, same amount of hydroxide neutralizes the same number of H plus ion in order to form water. So in order to fulfill this condition, so 4 moles of hydroxide must react with 4 moles of H plus ion. So that is how it's gonna work. So therefore the answer is D. Therefore the answer of this question is D, not B. Okay, B is the wrong answer, and D is the right answer. D is the answer. Okay, D is the answer to this question. Okay, fellas, that's the end of this solution. So fellas, let me give you something that you have missed earlier. Thanks for watching, fellas. It means a lot to me that you have stick till the end, even though the video video solution of this question paper is lengthy and it's taking time, but still you are supporting me by watching this video, and I really appreciate your effort. Okay, so congrats fellas, we have made it till the end. Help us improve our lessons by giving your feedback. Fellas, all I want is your feedback. Okay, so please give me feedback by giving like to this video or dislike. Both of them will do. You may give a like. If you don't like this video, at least give a dislike. Smash that dislike button or smash that like button. Okay, so if you have any question regarding this topic, concept, or anything else, please feel free to comment below. Okay, so here are the similar solutions like this one. If you find this solution helpful, here are the similar solutions. I'll provide the similar solution like this one of previous questions of this question paper over here. You may check it out by clicking here. Okay, you may find the solution of previous solution of this question paper over here. Okay, you may find the solution of previous question over here, so that you don't miss anything. Okay, so that's it. Okay fellas, if you are already our fellas, that's really great, we really appreciate. But if you are not, please click here to stay updated. Okay, so we will try our level best to complete this question paper as soon as